Take one. Genesis 1, episode 1. In the beginning. In the beginning.
I would like to introduce
FAU-GEM. Hello and welcome to FAU-GEM. My name is Lynn and I'll be your host for the day. Next to me is...
I'm Laura. We're both part of iGEM Erlangen. And today we're going to talk, as in all our podcast series, about previous iGEM projects. The way we structure the episodes is the following. First of all, we're going to introduce a bit the team that was behind the project that we're going to talk about. Second, we're going to explain a bit what's the problem they want to solve or improve in some way.
Exactly.
And third of all, we're going to talk about what's the solution they thought about, or to solve the problem or to tackle it in a better way to improve quality of life.
Okay, and so in the end, we basically want you to have a better impression of what iGEM can be, what projects you can do, and maybe even learn about a topic you didn't know anything about. For example, this episode, I didn't know anything about what we're going to talk about, and it's actually really interesting, so Stick around. Also, as a FYI, we'll be using their wiki page as a source and also some additional sources. But if you want to know the sources, you can message us and we'll provide them for you.
Yeah, definitely.
Okay, so first, we will introduce the team to you. Take it away, Laura.
The team we're going to talk about today was responsible for winning, actually, the undergrad grand prize in iGEM 2022. And they were team of Eindhoven University in the Netherlands.
Yes.
And the team was actually made of 9 ambitious master and bachelor students. As with many iGEM teams, they had like really different backgrounds. So in their wiki page, actually they tell us that they have expertise in biomedical engineering, but also like experience with entrepreneurship, stakeholder co-creation, and even graphic design, which if you look at the webpage, I think we can all agree on that.
Yeah, I mean, it's pretty amazing.
And now we will jump into the topic they wanted to deal with.
Exactly. So this team chose to deal with an autoimmune disease that is pretty rare across the world.
Fun fact, autoimmune diseases, they have like a prevalence of about 3 to 5% in our world population.
Exactly, and this autoimmune disease specifically is anti-neutrophil cytoplasmic antibody-associated vasculitis, or called AAV, is even rarer than that and can be life-threatening in some cases.
Not good.
Very aptly phrased, yes, not good. So first we should talk about AAV, what it is, because to be honest, I have never heard of it before.
Me neither.
So I'm going to just explain it pretty quick. AAV is an umbrella term for several different diseases. The disease the team from Eindhoven focused on is actually a specific one. It's also called GPA, which stands for granulomatosis with polyangiitis. So let's break those words down. What is granulomatosis, Laura? Oh wait, what's a granuloma? Because granulomatosis refers to granulomas in the body.
I know what a granuloma is. A granuloma is actually like an aggregate of immune cells. You usually find granulomas, for example, in diseases such as tuberculosis. So, for example, if we take like tuberculosis as an example, you get the bacteria, Mycobacterium tuberculosis.
Exactly.
And you get it in the lungs, for example, and you have like immune cells like macrophages, but you also get another cells like eosinophils, also like T cells are around there. And basically what they do is like surround the bacteria. They want to prevent it from spreading. And so they form like this aggregate that you can see when you take a CT or a scan of this kind, medical scan. You can see like a white spot in the lungs, for example.
Yes, it's basically just a ball surrounding all the things that the body cannot eliminate on its own.
Yeah.
So it chooses to encase it so it can't harm the body further.
Yeah.
And what is polyangiitis? Do you think you can figure that out?
Oof. I mean, if we go back to the roots and the etymological background.
Yeah, sure. Okay, it's fine.
Poly, it's multiple. Angio may have something to do with the blood vessels.
Yes.
And itis, it's something related to inflammation of some kind, right?
Yes, you basically got it. Polyangiitis is a multiple inflammation of various blood vessels, which lead to the low oxygen saturation of the tissue surrounding it, and then eventually to blood vessel necrosis. And when the blood vessels die, the organs which are normally they would supply with blood also die of low oxygen, and you have organ failure, which
it's not good. Again.
Yeah, not good.
Fun fact. If you want to sound like more medical or more professional, when you want to say like the tissues don't get enough oxygen, you would say hypoperfusion.
Ooh. So it just means low oxygen.
Yeah. Well, it's not only like low oxygen. It's when tissues don't get enough blood.
Very nice. So can sound fancy too. So, and because nothing is easy in immunology, even the sub-disease of a disease or sub-classification of a disease has their own sub-classifications. So AAV has a sub-disease which is GPA, which I explained to you, and GPA also has sub-diseases where you can divide it into different kinds. The team from Eindhoven chose to focus on chronic, systemic, and relapsing GPA, which is actually pretty common in autoimmune diseases, where you have a acute high inflammation, then it gets better for a while, and then you relapse. It sucks, actually. It reduces the quality of life quite a bit. And so they chose to focus on this because it's the most common type of AAV. The GPA is, or actually all AAVs are associated with the production of anti-neutrophil cytoplasmic antibodies, or ANCAs, or ANCAs. I'm just going to call it ANCAs for the podcast because, look, I don't know, and I'm too lazy to look it up. For the sake of time, yeah. So it's going to be ANCAs for now. Laura, do you know what an anti-neutrophil cytoplasmic antibody would be? Okay, so because it has antibodies on its name, I guess it's a type of immunoglobulin. What? Yes.
And these antibodies or immunoglobulin are directed against neutrophils, therefore anti-neutrophilic, or neutrophil, sorry. And cytoplasmic, I would say it has to do with the fact that the antigen they target is in the cytoplasm.
Exactly, that's exactly it. They target antigens that are in the cytoplasm of neutrophils, which is pretty weird because normally you would target antigens that are on the surface, but here they target the cytoplasm, which is pretty bad because one key factor of neutrophils is when they have an inflammation, they expel the cytoplasm and form nets. And so you have starting an inflammation with the neutrophils, and then you get the ANCAs going on top of that, but against their own body and not against the pathogen. So you get even more inflammation. Pretty terrible. Also, the antigens that they are against are usually enzymes. I think there's one that's called proteinase 3, and the other could be the myeloperoxidase. So it's usually enzymes in the cytoplasm that are associated with neutrophils. There are several theories how these ANCAs develop. There's one theory that it's associated with linked epitopes with pathogens, like super antigens and stuff like that. Sounds fine. It's also there's
not
also
your favorite theory,
no,
though.
not my favorite theory. It's also a thing that a lot of the patients which with AAV have chronic Staphylococcus aureus infection. So it could be like cross reactivity there. But my personal favorite is that it's with ineffective apoptosis. So you have these cell fragments floating around that get taken up by other cells and then presented, and boom, you have antigens, autoantigens, and pretty sucky. So at the moment, AAVs are treated with rituximab or corticosteroids, which is, if you've ever been in an immunology ward at a hospital, you know that every single patient there is on corticosteroids, because for now it's the best we have for a lot of the diseases which are so specific. And then rituximab.
It's an anti-CD20.
Oh, okay, so B cell marker.
Exactly.
Okay.
No, it's like rituximab is against
against the B cell marker.
Yeah,
so then
exactly.
it reduces the amounts of B cells you have, which
Exactly.
then in turn should reduce the amount of antibodies you
Exactly.
have, and then hopefully also reduces the amount of NCAs, but also the other antibodies, which leaves you a little bit more vulnerable to other infections that you'd have. Also, the corticosteroids there are several different corticosteroids, and not all of them effective. So if you have an autoimmune disease, they probably put you on several different one after another, because the one doesn't help, so we try a different one. It's very complicated,
and it's not the best treatment because they also have like
it doesn't treat the cause, it just treats the symptom, which doesn't help in the long run. Okay, so now you have a little bit of layman information about AAVs. Let's go to the project that they chose to do.
So this is the third part of the episode. So now we will see how they creatively thought about how to treat this disease in a better way instead of using corticosteroids and this rituximab.
So the project actually deals...
What was the name?
Oh, it's MPACT, but with a exclamation point as an I, which is kind of funny actually.
Yeah, it's like reverse I.
Oh yeah, also like in Spanish you have these other way.
Exactly, yeah.
It's so funny. Back to the topic. So the project is named MPACT, and they chose a novel technique that I personally actually had not heard before. The generalized extracellular molecule sensor, GEMS, system for their purposes, where they have an engineered receptor, well, not technically receptor, but an engineered transmembrane, let's just say receptor, which has
I think they call it like a modular synthetic receptor.
Oh, perfect then. Which has the scaffold of the erythropoietin receptor, and then on the extracellular that's fused to an antigen.
Yeah.
And on the intracellular part, it's fused to the signaling cascade of, for example, PI3K, ACT, or JAK-STAT, which is very common signaling for many cells to raise an inflammatory reaction, or is involved in so many different pathways. I don't have time to explain all of them today. But yeah, so they fuse it to an antigen, and then the ANCAs, the antibodies, bind to this antigen on the surface, which then induces through the JAK-STAT pathway, for example, and their goal is to induce IL-10 transcription.
Ooh.
And IL-10
is a cytokine, and it's an immunosuppressive cytokine.
Exactly. So they basically induce the expression, or the expression, what is like secretion of IL-10 once the ANCAs bind. So in the presence where the ANCAs bind, you have local secretion of IL-10, which is immunosuppressive. So even if the ANCAs bind, which normally would induce an inflammatory response, you have an anti-inflammatory response suppressing the negative effect of the antibodies, which is, I think, pretty clever actually.
I also think that it's like really, really smart. It kind of reminds me of CAR T-cell therapy.
It is similar.
But I think it is really, really, really smart. And do you know which cells express this ANCAs?
B cells.
Which cells?
Oh no, to which they bind them.
Yeah.
That is actually a big part of their, like they did a huge discussion on their page if you want to look it up, which cells to use to express these GEMs on. They decided between T cells and B cells, so these are the two they wanted to decide between. And I think they settled in the end, on T cells because it has more advantages for like an immune response, and they don't have to introduce the machinery to induce IL-10 because it's already there.
Yeah, I was going to say like T cells, Tregs are basically the best IL-10 cells, IL-10 secreting cells in our organism.
Exactly. So it's a little easier to do it with T cells because they're also very much in circulation. And I think maybe they even have higher frequencies in the blood. It's easier to, because to do this, you'd have to take blood from a patient,
Yeah, it takes
sort
a while.
out the T cells, modify the T cells, keep them in culture, reintroduce them, which is like a huge issue, especially also for CAR T cells, which use a very similar method. It's very expensive and sometimes doesn't work super well, or you have very small margins of success. So I think they settled on T cells in the end. That was their project.
I think it's also like really interesting for us as immunologists or prospective immunologists. We were really drawn into this project, and they actually have like quite a nice future outlook as well. Like they have like things they want to pursue. I mean, I think it actually has like a lot of potential as a therapy, and it would definitely help to improve the quality of life of a lot of the people that suffer the disease.
Yes, definitely, because the big advantage of these cell therapies is that you fight the disease with your own body, and you don't have to take extra medication that usually have high side effects, which is usually always reducing the quality of life for a lot of patients, especially for patients with AAV. On the website, they said that like almost 20 to 50% of patients are unemployed because you have these inflammations and then
these flares.
Yeah, it
very happens hard. With a lot of immune diseases. There's like the big problem with autoimmune diseases is actually the quality of life.
Yeah.
Because the body also has like some way of kind of like avoiding autoimmune diseases to become like a very threatening disease. Yeah. But because you have these acute phases, they really suck in this sense.
Also, some kill you. So that's pretty dark, but yeah, exactly.
Well, if you've gotten all the way through here, thank you very much for listening. If you are interested in this topic or if you want to learn more about it, we
only scratched the surface. There's much more.
Definitely, we could talk about this like for hours. But if you're interested and you also want to see like a bit more into detail, the wiki page of the Eindhoven team has like a really good description of the project, and they also have reference to other scientific papers. So if you want to be like an expert in ANCAs,
a good scientist,
exactly. If you want to become like the next ANCA expert, we highly recommend to look into this.
Yeah.
Stay tuned for further episodes and tell us what you think about this one.
Yep.
Bye-bye.
Thank you for listening. Bye.